Hello, this is part 2 of lesson 6. So we're on page 13. So again, these particular problems are time consuming because it can have a 3-for-1 problem, actually a 4-for-1, following up with a question. So again, let's review what we talked about. We discussed yesterday that if we have an equation, we want it to be in slope-intercept form for it to be linear. In particular, we do not want an exponent of more than 0 or 1 on the x value. So this equation already looks like it is not linear. In a table, we're looking for the change in all of our y values, which we have to find, is constant and it forms the same constant when we divide it by the change over our x values. And in a graph, we're looking for a straight line. So based on the equation, we don't think this is going to be linear, but let's prove it. So if you recall, we mentioned yesterday that when we use an exponent and I have a negative base, the number that we're giving us, so I'm replacing y or x with -2, and I'm going to raise it to the third power. Here's what has to happen in the calculator. We have to enclose that -2 in parentheses, then raise it to a power using this little key, and then the power that we want is 3, and we're going to press equals. You should get -8 as your y value. So we're going to do the same thing. We're going to take y equals, but this time we're going to enclose -1. We're going to raise it to the third power, and when we do, we're going to get back -1. That would be -1 times -1, which is +1, times the third -1, and a negative times a positive is a negative. If we take 0, that would be 0 times 0 times 0. We would get back 0. 1 to the third power would be 1 times 1 times 1, so we're going to get 1. And 2 to the third power means 2 times 2 times 2. And it sounds like that would be 6, but it was actually 8. 2 times 2 is 4, and 4 times 2 is 8. So now we have our table. If you look from this change in y to this, it's going down, it's going up 7. And that if I go from this change in y to this one, it's going up 1, so we have up 7, and we have up 1. Already this is not necessarily looking like it's going to be constant. However, sometimes based on what the x values are, it might be. So here I'm going up 1, and here I'm also going up 1. So 7 divided by 1 and 1 divided by 1 are not constant. So this is not a linear equation based on those two, but let's go ahead and finish this out. If I went to graph this, I would be graphing the first ordered pair, which is -2 and -8. So you're noticing that the scale is by 2s. We're going to go -2 on the x-axis, but the y-axis is by 2, so we're going to put -8. The next ordered pair is -1 and -1. So we're going to go -1, and -1 would be halfway in between here. 0, 0 is right at the origin, and now 1, 1 would be over 1, but up just a half because the y-axis is by 2s. And then this last ordered pair is 2, +8, so it's going to be placed here. So this is what this graph looks like. And again, it would pass a vertical line test. If you look at this, I don't know if you noticed, but it looks like this, it started to be a parabola, but it kind of turned upside down, and that's what happens when we have odd powers on negative numbers. So this is a function, but it is non-linear function. For any of the reasons, the equation, the table, or the graph, any of the reasons you want to state. Let's look at our fourth one. Y equals 1.5 or 1 5/10 times x plus 2. Does that look like it could possibly be in slope-intercept form? Yes, it could. And so let's build the table and see if we see a constant rate of change, and we'll build the graph and see if we see a straight line. It's looking promising so far. I'm going to go ahead and erase this. I'm just going to use this space above for my calculations. We're going to take y equals 1.5 or 1/5 times -4 plus 2. So that's 1.5 times -4, which would be -6 plus 2, and that would give us -4. And you're welcome to use your calculator for this. Next, we're going to replace our x value with -2, and -2 times 1.5 would be -3, plus 2 more would be -1. So -1 goes in this column. Now, third time around, we're going to replace x with 0, and 1.5 times 0 would be 0. 0 plus 2 is 2. So we're going to put 2 where this x is, and now we're on to our next x value of 2. 1.5 times 2 would be 3, and 3 plus 2 would be 5. And then last but not least, we're going to go ahead and replace this x value with our last number, which is 4. 1.5 times 4 would be 6, plus 2 more would be 8. So now let's check to see if we have a pattern or a constant of proportionality. If I change from -4 to -1, I'm going up 3. If I'm going from -4 to -2, I'm going up 2. So change in y is 3/2. Let's see if that happens repeatedly. So my change in y, -1 to 2, is going up 3. From 2 to 5 is going up 3. And from 5 to 8 is going up 3. If my change in x is the same, then we're confident it's linear. From -2 to 0 is up 2. From 0 to 2 is up 2. And from 2 to 4 is up 2. So we have a constant of 3/2. And if you think about that, if you converted 3/2 to decimal form, there's your slope. So your rate of change is also your slope. So now let's go ahead and try to graph this. I'm going to go to 0. I'm noticing again the y scale is by 2s. So I'm going to go -4 on my x, and then I'm going to go down 4. But remember, it's just two grid marks because the scale is by 2. I'm going to start at the origin again. I'm going to go -2 on the x-axis, but down 1, so that it has to be halfway in between. Whoops, it's a little bit bold of a point. I'm going to go to 0 on the x scale, but I have to go up 2, and you're noticing now that all of these are lining up. These points are lining up and making a straight line. The fourth point is 2 and 5, so again, I'm going to have to be halfway in between 4 and 5. It's not on a grid mark. And then the last point is 4 rather, and then up to 8. And all of these line up. This is a linear equation. We connect those points, draw an arrow to notice that they go on forever, and yes, this is linear. Okay, last one. This one is going to make kind of an unusual graph. So we're going to start with y equals, and this time I'm just going to go and replace right in the equation. 12 divided by 1. Well, that would be 12. The y value would be 12. So now let's erase that, and we're going to say 12 divided by 2, and that would give us 6. So we're on to 3. 12 divided by 3 would give us 4. Our fourth x value would be the number 4. So 12 divided by 4 is going to give us 3. And then last but not least, our final x value is 6. So we're going to replace that x with 6. 12 divided by 6 is 2. So this equation. I don't know if you recall what we talked about, having an x in the denominator, but let's kind of see what we see with the rate of change, as well as what's going to happen when we try to graph it. So if I'm going, my change in my y's, I'm going down 6. My change in my x's, I'm going up 1. So far that's 6 over 1. My change in my y's would be down 2. My change in my x's are still up 1. So now I have down 2 over 1. So negative 6 over 1 and negative 2 over 1 is not constant. So I know it's not linear based on the table. And what would the graph look like? Well, I'd have to go 1 and then up to 12. So 1 and up to 12. So 2, and then I go to 6 on the y-axis. Then 3, and I go to 4. Well, that already doesn't look like it's straight. Then I go to 4, and that's at 3, and then I go to 6, and that's at 2. So we can see already this is making a curved figure. So it is nonlinear. Okay, would you please take a moment and spot what are the differences you noticed about the equations that were linear and those were not, and what's the difference you noticed about the tables that were linear and those were not. Thanks for listening. Have an awesome day.